Hello, everyone. My name is Mauricio Velasco, and I'm part of Splunk's threat research team. In this short video, we're going to be going over the new analytics story we have released called Active Directory Kerberos attacks. This analytics story, of course, focuses on detecting and hunting for Kerberos attacks. As part of our presentation, we will also go over a few demos where we're going to execute attacks in our lab environment and detect them using Splunk. Let's go ahead and start. We're going to start with a high-level description of Kerberos. It is not the intention of this video to describe Kerberos, but at a high level, Kerberos is a network authentication protocol used by default on Active Directory networks. It works on the basis of issuing tickets by a trusted third party called the KDC, the Key Distribution Center, which is typically the domain controller. The domain controller issues tickets for people to get access to the network and resources. When you first log in and type in your password, you first get a TGT, a ticket granting ticket. As you want to consume services in the network, for example, connect to a web server or connect to a file share or connect to a SQL database, you're going to be requesting service tickets using your TGT. That's at a high level, Kerberos. Now, we wrote this analytics story to detect Kerberos attacks, but why should you care? Well, as the backbone of Active Directory authentication, Kerberos is going to be commonly abused by adversaries across the different phases of a breach, right? We believe that it is important for defenders to have an understanding of what are those types of attacks that abuse Kerberos and how to detect them. So this is why we wrote the Active Directory Kerberos attack analytics story. As it is now, it has 24 detection analytics covering more than 10 different types of Kerberos attacks. It focuses on the following data sources, of course, Kerberos events. We also use process execution and command line logging. And we also use PowerShell script log logging. This analytics story is a work in progress. We will continue to add new detections for different attacks and different ways of detecting it, right? So we're gonna now jump to the demo. In this demo, we're gonna be using a lab environment built with the attack range. Of course, Splunk login in this environment. And to execute some of the techniques or simulate some of the attacks, we're going to be using three tools: Rubius, Kerberos, and Purple Sharp. So for this demo, we're going to be talking about three different attacks. Now, it is not the goal of this presentation to dive deep into the attack. So I'm just going to give a quick, short, high-level summary of each one of the attacks. The first demo is user enumeration. So in this demo, an attacker is going to abuse the Kerberos protocol to validate if a list of users are valid domain users or not. So a way to do discovery in the network. On the second demo, we're going to be using the overpass the hash technique, which I see a typo here, but the overpass the hash technique allows an attacker to leverage installing NTLM hash to then obtain a TGT, a ticket granting ticket, basically impersonating a user using its NTLM hash, and then to then consume services as this user. So we still hash for an administrative user, we get a TGT, and then we can start consuming Kerberos services impersonating this user. And the last attack is Kerberosing. By this attack, attackers are going to be requesting service ticket events for service principal names. And the goal of the attack is to obtain passwords. So what happens is when you get a service ticket for an SPN associated with a domain account or a service account, part of this ticket is encrypted with the password of this service account. So we can try to crack this ticket and obtain the password for this service account, which may have interesting privileges on the network, right? So let's go ahead and start with our first attack. So for our first attack, we're going to be using a tool called Kerberos from our Kali Linux. first, I'm going to show you this list of users that I have here. These are 200 users that are, let's call it non-valid users on our network. So we're going to be using the Kerberos with user enumeration. We pass the range, the domain, and we pass the IP address. So this tool is really fast. It performed this in under, wow, 0.027 seconds, 200 tests. So what happens is now we know that none of these 200 users are valid, right? And if we look at our Splunk query, we're going to detect this, we're going to be using an event, the event called 4768, which is TGT was requested. Particularly, we're going to be focusing on a particular field called result codes. This field is an interesting field, and one of the possible values for this result code is 0x6, which means the username does not exist. It's not on the Kerberos database. So this is going to be our first query. We're looking for 4768 events with this result code, and we're narrowing down so that we're only looking for actual user accounts and not computer accounts. So we don't want that extra noise, right? And as we can see here, at this time, this IP address, which should be our Kali Linux IP, try to, trigger this on this particular search and try to enumerate 200 users, and all of them were non-valid, right? So this is an interesting first query to start hunting in the environment for who is enumerating a large number of accounts that maybe don't exist, right? But if we want to translate this to an actual secure operations analytic, meaning like a real-time detection, we need to add some logic. In this case, the logic that we added was we're going to use some statistics, and I'm not going to try attempt to describe the query here in this short video, but what we're using is leveraging Splunk's ability to perform some statistic analysis and use the standard deviation to identify outliers. So in this case, we are able to identify these requests or these events as an outlier, because this particular client address or IP address perform an unusual large number of service tickets requests. So we can use this query to detect as a detection that runs every 30 minutes or so, right? So this is the first attack. Let's move on to the second attack. As I mentioned, in an overpass the hash technique, once an attacker has stolen an NTLM hash, he's then able to request a TGT using the stolen NTLM. So first, you're going to see here that we have no tickets on our current session, and we're going to use the tool Rubius to obtain a TGT for this user Christina Pope, for which we have stolen the NTLM hash, right? We're assuming that we have stolen this, right? So if we execute this command, Rubius connects to the domain controller, uses this NTLM hash to actually obtain a TGT. So now we have a TGT in memory for this user. So if this user is a server administrator, a domain administrator, or any type of administrator, we can then start consuming these services as this user, impersonating this user. So if we go back to the detection, there's another interesting field on the 4768 event, TGT was requested, and the field is the encryption type. And according to Microsoft documentation, an encryption type of RC4, which is 0x17, it's a default suite for operating systems before Server 2008 and Vista. So if we have like relatively modern environments, in theory, we shouldn't be seeing this type of encryption, right? So this is why we use these fields, encryption type, to detect a potential overpass the hash technique by using an NTLM hash. Okay, and finally, our last attack or simulation of the day is Kerberos. So for this, we're going to use Purple Sharp, and we have a JSON playbook here. Let me enable this playbook. So what this playbook is going to do is going to request a service ticket for all the SPNs that it finds on the network. So Purple Sharp will perform LDAP queries to first obtain the SPNs and then obtain a Kerberos ticket, a Kerberos service ticket for each one of them in one shot, right? So we run this, and let me just make sure that we have the right playbook enabled. Yep. So when we execute this, Purple Sharp is able to identify 30 SPNs and then try to obtain a service ticket for each one of them. Okay. Now we go back to our log, and this time we're going to use event 4769, which is service ticket was requested. And particularly, once again, we're going to be using the RC4 encryption type. And one interesting thing is look at the service name field, because we want to avoid the service ticket requests that are focused on computer accounts. So we add this to focus on service tickets for actual SPNs. So we run this, and we actually see that this IP address obtained 30 service tickets. And these are the requested services, right? So again, this is like a starting query where we can use to hunt, but we cannot really use this for detection like on a real time, right? Which is why once again, I decided to use the standard deviation statistical analysis to detect outliers for IP addresses that request an unusual number of service tickets. In this case, we find the outlier using standard deviation. Now, as a final thought, I wanted to share something else. If you think about this attack is kind of like fast because it's trying to obtain all service tickets at the same time. What if the attacker adds a sleep time of, let's say, 5 seconds between each service ticket request? So we have this playbook that Purple Sharp executes where we add a sleep time. And if we run this, we should see that there's going to be a 5-second gap between each service ticket request, as we can see, right? Now, of course, we could change this to be 30 seconds or 60 seconds or 1 hour. My question to you, blue team, is can you detect a low and slow Kerberos attack? That's something to think about, right? But that is it for me. These are just some resources I want to leave you guys. If you want to know more about the analytics story or the Splunk Study research team content, I appreciate your time and attention, and I'll see you next time. Thank you. Bye.